for every one oxygen, so that we have 2 plus total and 2 minus total. The way we write that then is with a subscript 2. So the compound sodium oxide would be Na2O. Like that. And this tells us that there's 2 sodiums for every oxide, because we've got +1 on the sodium, -2 on the oxygen. Good so far? Maybe? Think about it? Okay. All right, let's try another one. Let's look at aluminum oxide. So we already talked about building aluminum, so you can go back in your notes and check that one. And we just talked about oxide. So we know oxide is -2. What is aluminum? -3. Or +3, sorry, +3. All right, so how do we put together a +3 and a -2 to make it neutral? No, you're thinking about something later, but you're on the right track. You're on the right track. So we're going to figure out how those subscripts go. But this one gets a little tricky, because if you have, let's count them out here. If we have 1 aluminum and 1 oxide, they don't balance, right? 3 plus, 2 minus, so we got 1 plus left over. So we add another oxygen, or another oxide. But now what do we have? A minus left over, yeah, because we got 4 minus and 3 plus. So let's add another 3 plus to balance that out. Well, now we got 6 plus and 4 minus. So we're 2 over on the plus side. But that actually works, because if we add 1 more of these, now we've got a total of 6 plus and 6 minus. Now we're good. So you can kind of keep going back and forth until you get it to balance out. Another way of thinking about that is called the least common multiple. But you can just balance back and forth, and it works too. So the way we would write that formula then is Al2O3. To show that we need 2 aluminums and 3 oxygens. And for us, it's not going to get much weirder than that. We'll do some of these 3s and 2s, but we won't really get into like 4s and 5s and whatever else. So, okay, let's take it there. Okay, so getting into these names a little bit, we're going to go through the rules of how to name things, but we're not going to do that just yet. There's another way that we'll see some compounds written, and it tells us what to do with these weird things in the middle that we don't know what to do with. So here's a compound that you might see. Whoops. I want to do that. Okay, I want to do that. Copper, and then a 2 in parentheses, and then oxide. Copper 2 oxide. So what does that mean? Well, okay, oxide's still oxide. We know what that is. It's oxygen 2 minus. Copper is Cu. We can look that up in the periodic table. But that one's in the Bs. So we don't know what to do about its valence electrons. It doesn't have a kind of predictable thing. And in fact, copper can have multiple different charges. It doesn't just have one. So there's no way, if you just say copper, that you know what the charge is. So whenever we specify a metal like that, a transition element, we actually specify the charge in those parentheses. So that little 2 tells us to make it a 2+ ion. Metals are always positively charged. So whatever that number is in the parentheses, that Roman numeral number, tells us what the charge should be on the metal ion. Now that we know that it's 2+, we can put that compound together. How would you put that compound together? What would be your final formula for copper 2 oxide? CuO, right. Because it's 2+, 2-, they work out. All right, now another compound that also exists is copper 1 oxide. What would its formula be? See if you can build a formula for copper 1 oxide using the same idea. Okay. So what'd you come up with? Cu2O, right, yeah. So you saw that copper, we use that little 1 to know that it's going to be +1. Oxide is still oxide, which is always -2. So now we've got a +1 and a 2-. So we have to make 2 of the +1s to balance out the 2-. Because you got to have the same number of plus and the same number of minus overall. So that's how you deal with those middle ones. So the charge has to be specified because we don't know otherwise. All right, so that's how to build compounds. So now let's go the other direction. And this is, I'm not gonna say it's hard, but it certainly takes a lot of practice. Let's look at the rules for naming ionic compounds. So first, we're going to split them up into 2 groups. When you look at a compound, we're going to figure out which group this compound fits in. It's either going to be a variable charge or a fixed charge. How do we figure that out? Oh, I'm sorry, I should be more specific here. Is the metal so we've got a compound, we want to figure out what to call it. We first need to ask, is the metal a fixed or variable charge? What does that mean? How do we tell that? What is that? Hold on. Go ahead. Not quite. That's a good idea, but you could do that either way. So actually, that would work for either of these. Do you want to? Okay, but she said that you wouldn't have to like balance them out with the other thing.
I was going to say like if there's no number next to the metal.
Sort of. It's actually the opposite because we're going the other way now. We're going to look at a symbol and figure out how to name it. So yeah, but again, you're on the right track. It's basically, is the metal in that middle weird region or not? So the fixed ones are the ones that we know just by looking at the table or by doing the buckets, all the ones that we've just been dealing with. So we're talking about column 1A, 2A, 3A. Well, actually, that's not quite right. Just aluminum works in 3A. Then we've got 6A and 7A. And there's a few other ones, but we won't maybe mess with them. The ones that we can do the buckets and we can figure out. Variable charge is everything else. All the stuff in the middle that can have different kinds of charges. So let's look at an example and see how we would do that. CaCl2. So our first question, is the metal fixed or variable charge? So we would look at calcium and say, can calcium have more than one different kind of charge, or is it always going to have the same charge? So what do you think? Could it have different charges or always the same? Same, always the same. How do you know? Yeah, those two columns to the left of the transition metals always have the same charges. They're always +1 and +2, just like their group number says. So we're going to say that this one is fixed. Calcium only is +2, always +2. Okay, so once we figure that out, the rest of the name is pretty easy. If it's fixed, there's only one kind of charge, then our name is just going to be the metal and the non-metal plus this IDE at the end. So we don't put any numbers into the name if it's a fixed charge. So I guess that's 2. All right, so once we determine it's fixed, we can just write down the name as the metal, and then the non-metal, we pull off the suffix and we put in IDE instead. So we would call this calcium chloride. Calcium and then chlorine, but we take out off the ene and make ide instead. So calcium chloride. All right, try this one. You may need to look up some names here, but that's okay. Good try. I mean, the technique was correct. I think you looked up the name right. Anybody look it up? What's SR? Strontium, yeah. So then the name would be? Yep. Oh, close. You threw in the ox. That's different. Sulfide, yeah. Yep. So again, it's a fixed charge just below calcium. So we call that strontium sulfide. So this is why those charges and all that stuff are so important. We don't specify the number of each thing in the name. We don't call the first one calcium dichloride or something like that to show that there's 2 of them. And it's because of their predictable charges, we have to be able to predict what that formula is going to be using the techniques that we did before. All right, so let's look at the other class of these, and then we'll have some time to practice before we'll throw one more thing in there, and then we'll practice. If we have a metal that can have a variable charge, can have different charges, just like we did up here, we have to specify that charge in a Roman numeral. So we're going to write that metal name again. Then we're going to put the charge in the parentheses. And then again have the nonmetal plus ide. This can be a little tricky because we have to calculate the charge based on the formula. So let's see how that works. All right, let's say I want to come up with a name for FeCl3. So first rule again, or first thing again, is it a fixed or variable charge metal? So this time it's variable. And we know that because we look up at the periodic table and we find Fe kind of in the middle. And anything in the middle, we're going to say, okay, that's variable. So we're going to have to be careful with that one. All right. So now, in order to write the name, most of the name is pretty easy. We just write, we look up that Fe is iron, so we can write iron. And then we'll just put a blank here because we know we're going to have to put some charge in there. And then we write chloride. So then the tricky part is, what number do we put in there? What is the charge on that iron? Any idea how to figure that out? Yeah, so whenever we have a situation like this, the other part of it, the non-metal part of it, is always going to have a predictable charge. So what's the charge on chlorine usually, chloride? May have to look back on this one again, but we've done it a couple times. Anybody remember? It's minus how many? Just one, right. So chloride is always -1. So we can figure this out. The overall compound is neutral. Chloride has to be -1. It might help to just write this out like this. We've got one Fe, and we've got 3 Cls. They're all -1. So what's the overall negative charge in this formula? -3. So what does the charge on iron have to be to balance that out? +3, right. You see how that works? The overall compound has to be neutral. So if we've got an overall -3, then we have to have +3 also. And so that tells us that we put a 3 in the parentheses. Now we got to be careful with this because it's really tempting to say that 3 should be like the subscript number. And in this case, it kind of is. But that doesn't always work out like that. So that's not a good rule. It's a rule that we want to think of, but it's not a good rule. Forget that rule. Don't use that rule. All right, let's try another one. See if you can figure this one out. TiO2. What would you name that compound? What?
Titanium oxide.
Close. So we gotta figure out whether it's variable or fixed, and then if it's variable, determine the charge on the metal. Anybody feeling good about this one? Yeah, are you okay? What do you get? Close. But you're on the right track.
-4.
Close. All right, let's take a look at it together. You're all super close. So we figured out that it's the variable charge because it's in the middle. So the name is going to be something like titanium something oxide. Okay. So what's the something? Let's figure it out. What's oxide's charge always? -2. Yeah. And again, the more you practice this, the more you'll get used to these. When you first start, you have to keep going back to the valence electrons and the buckets and stuff, and that's fine, but we do a lot of practice and then you'll get it. So our formula tells us that for one titanium atom, because there's no little subscript under the Ti, that just means there's one, we've got 2 oxides. We got 2 oxides, each one is -2. So what does the charge on titanium have to be to balance out those 2 -2s? +4, right? So that means that our number in parentheses is going to be that charge, which is 4. So we call this titanium 4 oxide. All right, let's try another one. Try a couple of them here. Let's try Ni2S3 and COCl2. And if you get both of those, try ALP. Feel free to work together on these if you want to try to figure it out. Let me know if you're stuck on something. So remember, the tricky thing with these second types, you can't get the charge from the electrons. You have to look at the other one. So like this nickel Ni2S3, you can't figure out the charge on nickel just by knowing that it's nickel and it's 28. You have to use the sulfur. You can figure out the sulfide and then calculate what the nickel switch would be for the charge. So, yeah, like we did with the iron above and the titanium. So the nickel, yeah, you get it. So you had to figure it out from the sulfide and use the nickel itself because it's the ones in here.
No, there's just 2 of them.
All right, I want to go through these. First of all, don't get discouraged if you're not getting this yet. This is a lot of stuff for one day because we went all the way from this is how many electrons there are to here are the charges to here are the compounds that you can make from those charges. And so each of those steps takes some work and some homework. So don't worry if you're not putting this all together right now because that's a lot for one day. That's the problem with a class set up like this when we do it all on Monday. So hopefully throughout the week as we do practice and homework and take little steps, it'll become clearer. But let's take a look at how we would step through each of these. So the first one, Ni2S3. One way to do this, which I saw a lot of people doing and I think is a good way to do it, is just write down what that formula means, just literally. So if you see Ni2S3, that literally means 2 Nis and 3 S's. And don't even worry about the charges at first. That's just what that means. So you can just write those down, and you can't add any more. You can't take them away. That's what the formula tells you. That's what you got. So now we can start slowly adding in the charges and trying to figure out what else we do here. I should also note, I guess I skipped thinking because I've been talking to everybody about it, but this is a variable charge compound, which means the nickel is in the middle, so we can't figure out what charge it has based on its electrons. We can only figure it out based on the compound. So the name, so we can write down the formula literally, and I'm just going to move this out of the way so we can write it. And we can write down that we know the name is going to take this type of form, nickel something sulfide. I also saw some different spellings and things of these. Don't worry too much about that now. I won't mark that wrong if you write sulfuride or something, or something that's a little bit different. We'll get that. So it's nickel something sulfide, and we've got the literal translation of that formula is 2 Nis and 3 S's. So now we can start to figure out the charges. The nickel we don't know, so we have to base it on the sulfur. So we have to know the charge of the sulfide. And so did anybody figure out, what method did you use to figure out the charge of sulfide? Anybody? Buckets. So the buckets is one way to do it. You fill up the buckets with 16 electrons, and then you notice that you can either take out 6 or add 2 to the last one. So you're going to add 2, and that's going to make it 2 minus. That's one way to do it, and that works. As you do your homework and as you keep working through these problems, I think you'll find that a little tedious. So you'll start to use more of the shortcuts, like noticing that everything that's 2 away from the right is always -2 and things like that. But the buckets always work, so you can always go back to that if you need to. Yeah. Question. Yeah, so that would be another one. Like you just count how far away it is from the noble gases, and it's minus for every one you go right, and then when you start jumping to the other side, it goes to plus again. Everybody has their little tricks for how they like to do it. There's the tops of the columns that can help you out. Whatever works for you. If you're more of a memorized type person, you could just literally memorize those charges separately, whatever, as long as you can get those charges somehow. That's all that counts. So we figure out in some way that these are each going to be -2. And now we can look at our overall negative charge and try to balance it out with our overall positive charge. So our overall negative charge on sulfur is -6 now because we've got 3 -2s. And so that tells us that our overall positive charge has to also be -6. And there's nothing wrong with writing this down also. So you could add all these up and say, okay, I know overall this is all adding up to -6. And so that tells me that overall my positives have to be +6 to balance that out. So then the very last question is, what charge does each nickel have to fit all this stuff that we just wrote down? And so what charge does it have to? It has to be +3. You see why that is? From all the stuff we just did, we figured out that we need +6 total charge, and we only have 2 nickel atoms to work with. So each of them has to be +3 to make that work. Any other number there doesn't work. That's the only way we can get to that 6. All right, so then we can finally finish our name where we put a 3, a Roman numeral 3, in the parentheses and say that this is nickel 3 sulfide.
That's how you say it? Nickel 3 sulfide?
Nickel 3 sulfide, yep.
It just doesn't have like a ring to it.
What do you want to call it? Should we pick out something else? I don't know.
Like the try or die.
Yeah, so what is the deal with all of that? It does sound better. Yeah. The reason this is like this is that for most compounds they have what's called a common name. So like sodium chloride is table salt, right? There's all kinds of different ones. Potassium nitrate is saltpeter. I don't know. I'm trying to think of other ones. Antimony sulfide is stibnite. There's a whole bunch. Like they have these names, and before these rules came about, part of chemistry was just learning every name. So chemistry was like worse than anatomy. Well, I don't know if I go that far, but you just lists and lists of like just random names that you have to remember of what stuff was called and what the formula was for those things. So instead, we have these rules so that we can systematically say, okay, any name I get, I can always figure out the compound, or I can always figure out the formula. And any formula I have, I can always figure out the name. So that way we can communicate well. Now, if you look these things up, like when we're looking things up for safety, you'll often find some of these older names. You'll find different ways of naming it, like calling this nickel trisulfide or something like that. Yeah, so there's different ways. Those mean different things too. So even though that sounds better, it actually becomes more confusing because it doesn't give you as specific. But yeah, if it could be more confusing. I mean confusing from like the standpoint of you don't know which compound you're talking about. So that's why we stick to these rules. And in fact, we will use those types of names, but we'll reserve them for what we call molecular compounds, or compounds that are not ions, that we'll talk about on Wednesday. So that's why we do it this way, so that we can always know what each other's talking about when we communicate about chemical compounds. All right, so on to the next one, same technique. We're going to first just write down what we've got and whatever kind of shell of a name we can get. So COCl2, CO is cobalt, that's number 27. So what kind of a name is that going to give us? Is this going to be fixed or variable? Variable, right? So we're going to use the Roman numerals, the parentheses. Okay. And we can go about it the same way. We can write down that our formula gives us 1 CO and 2 CLs. We can use whatever technique we want from what we've been talking about to figure out the charge on Cl, which is chloride is a -1 charge. And then we add up the charges and make them balance. So 2 -1s is a total of -2. And so the cobalt then has to be what to balance that out? +2. So that means that a 2 goes in the parentheses here. The charge on the metal always tells us what goes in the parentheses. Okay, and the last one down here, ALP. What are we gonna, which category does that fit into? Is that fixed or variable charge, aluminum? Yeah, this one's a little tricky because aluminum isn't really in the middle, but it kind of is. But aluminum is one of the exceptions where it's fixed. And we used that as one of our examples earlier, that aluminum being in the third column is actually always +3. So the other ones underneath the staircase there, kind of on the right side of the metals, actually are variable. So things like GA and IN and TL and SN and PB, those are variable, even though they're over kind of closer to the non-metals. But aluminum is always the same, is always +3. So that means that we can name this without going through all that charge nonsense and just call it aluminum. Yeah, and this would be phosphide from phosphorus. Now, if you wrote phosphoride, that's fine. I mean, it is phosphide, but I wouldn't mark it wrong if you wrote phosphoride. If you use the British spelling of aluminum, which is aluminium, actually has a separate I on there, that's fine too. Those are both correct names for it. But what would not be correct here, it would not be correct to put a 3 in parentheses here. Even though the charge on aluminum is 3, it's always 3, so that's fixed. So we don't specify the charge. All right, that was a lot of stuff. So sorry if I broke your brain, but I think it'll be okay. Just work through the homework problems, practice, send me messages if you get stuck or if you need help. Go to the tutoring center, they do a nice job over there also. And yeah, I'll see you Wednesday for lab, and we'll do more of this on Wednesday. It's more fun.